Hello, lovely people. Welcome back to our channel. Today we have got a fascinating topic lined up for you. We will be diving into the world of simultaneous equations where one of them happens to be quadratic. Stick around because by the end of this video, you will have a solid understanding of how to solve these equations like a pro. But before we get started, if you are new here, don't forget to hit the subscribe button and ring the notification bell so you never miss out on our exciting maths tutorials. Example 1. Before I start, I just want to remind you, I speak slowly, and if you want, you can watch these videos on 1.5x so that you can review it quicker. So we will start with our example 1. Now for example 1, we have got solve the simultaneous equation. So clear algebraic working, we have got a linear equation here which is y is equal to 7 minus 2x, and then we have got a quadratic, like here I have got x square plus y square is equal to 34. It's actually, if you will draw this graph, you will get a circle. So let's see how we can solve this type of quadratic. So we have got y is equal to 7 minus 2x, and we have x square. So we are going to use the substitution method. I can replace this y square with 7 minus 2x whole square, and that should be equal to 34. So it implies that I am going to expand the bracket. So x square plus 49 minus 28x plus 4x square is equal to 34. Now I will bring everything to one side and I will try to rearrange it. I will write all the common terms together. So x square and 4x square will give me 5x square minus 28x plus 49, and I will bring this 34 to the left hand side, which means I am subtracting 34 from both sides. So I will be left with negative 49 minus 34, and 34 minus 34 is 0. So this will give us 5x square minus 28x plus 15 equal to 0. Now let's see what we can do. We have got a quadratic and we can solve this quadratic by factorizing. So in my previous video where I have discussed how to use factorizing in order to solve a quadratic, you can watch it if you haven't watched it earlier. The link is available in the corner. So let's see. Here my a is 5, my b is negative 28, and my c is 15. So let's write 5 times 15 is 75. So the factors of 75 are 1 and 75, 3 and 25, and you can notice 3 and 25 can give us 28 as well. So I can rewrite this expression as, or this equation as, 5x square minus 25x minus 3x plus 15 equal to 0. Clearly, when I will multiply negative 25 with negative 3, my result would be positive 75. And when I add them, I will get negative 28. So let's group them in, pair them in two, and we will create parentheses. So here I can take out 5x outside. I'll be left with x minus 5. And from here I can take negative 3 outside. I'll be left with x minus 5 equal to 0. You can see we have got the same terms over here. That means I can combine these two together. So 5x minus 3 times x minus 5 equal to 0. If the two numbers are multiplied and their product is equal to 0, that means one of them is 0. So it implies that either 5 minus 3 is equal to 0 or x minus 5 is equal to 0. We'll continue on the right hand side. So it implies that 5x is equal to 3 or x is equal to 5. It implies that x is equal to 3 by 5 or x is equal to 5. Now we have got two values of x. Let's plug it back in the first equation to get the value of y. So we have When x is equal to 3 over 5, using the equation y equal to 7 minus 2x, which is our first equation, we can get, I am going to substitute the value of x as 3 over 5 in this equation. I will have y is equal to 7 minus 2 times 3 over 5. It implies that y is equal to 7 minus 6 over 5. It implies that I can take the LCM 5, so I'll be left with 35 minus 6. It implies that y is equal to 29 over 5. Similarly, here when x is equal to 5, what's gonna be the corresponding y values? So using the equation y is equal to 7 minus 2x, it implies that y is equal to 7 minus 2 times 5. I am substituting this value of x in order to find the corresponding y value. So we'll have y is equal to 7 minus 10. It implies that y is equal to negative 3. So our points are 3 over 5 comma 29 over 5. We always write x first, and the other point is 5 minus negative 3. 5 comma negative 3. So let's see how it will look like on the graph. Here I have plotted the graph of the two given equation. So we had y is equal to 7 minus 2x, which is a straight line over here. So this one is our y is equal to 7 minus 2x. And another one which I was telling you that if you will plot it, it will look like a circle. So this is the equation of a circle whose radius is at origin and whose center is at origin and whose radius is root under 34. So when I have plotted it, when I am trying to solve the simultaneous equation, the graphical interpretation of solving simultaneous equation is finding the point of intersection of the two curves. So you can see they are intersecting here at 0.6 comma 5.8, which is 3 over 5 comma 29 over 5, and the second point that we are getting is 5 comma minus 3, and we have got these points using the algebraic method. So you can rewind it and you can see this is how you can get the point of intersection of the two curve when one is linear and another one is quadratic. Example number 2. This one is also similar to the previous example. We have got two equations. The first one is quadratic and the second one is linear. So how we can solve it? So in order to solve this pair of simultaneous equations, what I am going to do, I will first write my second equation, which is x minus 2y equal to 1, and I will make x my subject. So x is equal to 2y plus 1. Now I have x is equal to 2y plus 1. I will substitute this x back in the equation 1. So what I will do, I will replace the x with 2y plus 1. Let's see how it will look like. So I have 3, replace this x by 2y plus 1, and I had a y already, so I will write it as 3y times 2y plus 1 minus y square is equal to 8. So it implies that, let's expand the bracket. So we will have 6y square plus 3y minus y square is equal to 8. What we can do, we can combine the like terms together. So we will have 5y square plus 3y minus 8 is equal to 0. So it is a quadratic equation and we can solve it by factorization. You can see your a is 5, your b is 3, your c is negative 8, and a times c is negative 40. So if you write the factors of 40, you will get 1 and 40, 2 and 20. You will have not 3, 4 and 10, and 5 and 8, and 5 and 8 will do, because if you will write 8 minus 5 you will get 3, and 8 times minus 5 is negative 40. So that is the most suitable one. Let's start. So 5y square, I can rewrite this 3y as 8y minus 5y minus 8 is equal to 0. So we'll pair them and we will factorize them. So factorizing it means you have to put a parenthesis and write the common factor outside of it. So it's just opposite of expanding bracket. So between 5y square and 8y you can take y outside, and under the parenthesis you will just have 5y plus 8, and between negative 5y and negative 8 you can take out negative 1. So 5y plus 8 equal to 0. You want these two terms to be the same. If you have them same, you can write these two together, which is y minus 1 times 5y plus 8 equal to 0. It implies that if the product of two numbers is 0, it means one of them is 0. So either y minus 1 is 0 or 5y plus 8 is equal to 0. That will give us y is equal to 1, or 5y equals to negative 8. It implies that y is equal to negative 8 over 5. So let's find the corresponding x value. We know that our x is equal to, our x was equal to, x is equal to 2y plus 1. So when y is equal to 1, my corresponding x value would be 2 times 1 plus 1, which means x is equal to 3. And when my y is equal to negative 8 over 5, my corresponding x value would be 2 times negative 8 over 5 plus 1, which is negative 16 over 5 plus 1. It implies that x is equal to negative 16 plus 5 over 5, which means x is equal to negative 11 over 5. So let's write them properly like a coordinate. So 3 comma 1, and the second coordinate that we have got is negative 11 over 5 comma negative 8 over 5. So like we have done in the previous case, we will see the graphical interpretation of solving these simultaneous equations in the next page. So here I have plotted the graph for you. The first one is 3xy minus y squared is equal to 8. That is given by this blue graph, and the straight line is x minus 2y is equal to 1. You can see the points that we got. They are 3 comma 1 and negative 2.2 comma negative 1.6, which is basically negative 11 over 5 comma negative 8 over 5. So you can see solving simultaneous equation is finding the point of intersection of two curves. Now these questions can be asked and they can be rephrased as find the point of intersection of these two curves. So what you're supposed to do, you will be using the substitution method. You make x or y your subject, you substitute this value back in the other equation, you will get a quadratic and you can solve it. So we have already done two examples. Now I'm going to do the third one. And for third one, what I will recommend, as soon as I will show you the question, you pause the video and try attempting it by yourself. All right, fellas, so we have got our third question now. Now the third question is same. We have got solve the simultaneous equation. We have got two equations and we have to show our algebraic working clearly. So you can pause this video and you can attempt solving it. All right, so I believe you have tried solving it. This one we have already got y as a subject. The second equation is y is equal to 2x minus 3. So let's substitute this value of y back in the previous equation. So we have 3x square plus 2x minus 3 whole square. I'm replacing this y square by 2x minus 3 whole square minus x times 2x minus 3 is equal to 5. So we'll solve it now. Let's expand the bracket. So 3x squared plus 4x squared minus 12x plus 9 minus 2x squared plus 3x is equal to 5. And let's combine all the like terms together. So 3 4s, that is 7, 7 minus 2 is 5. So 5x squared, negative 12x and positive 3x. That will give me negative 9x. And then I have 9 and plus 9. Let's subtract 5 from both sides so that we can get rid of this 5. So we'll be left with 5x squared minus 9x plus 4 equal to 0. So A is 5, C is C, so 5 times 4, which is 20, and we can take 5 and 4 in order to get our negative 9. So what I am going to do, I will rewrite this negative 9x as negative 5x, negative 4x plus 4 equal to 0. Again, we have to pair them and create a parenthesis. So I will take out x, or I can take 5x common. So I will have x minus 1, and from here I can take negative 4 common, x minus 1 equal to 0. We have the same terms here. We can just combine these two. So I have 5x minus 4 times x minus 1 equal to 0. The product of two numbers is 0. It means one of them is 0. That means 5x minus 4 is equal to 0, or x minus 1 is equal to 0. It means x is equal to 4 over 5, or x is equal to 1. So we have got our x values. Let's find their corresponding y value. So the equation that was given to us was y is equal to 2x minus 3. So for x is equal to 4 over 5, y is equal to 2 times 4 over 5 minus 3. That is 8 over 5 minus 3. It implies that y is equal to 8 minus 15 over 5. It implies that y is equal to negative 7 over 5. Let's see, when x is equal to 1, let's find the corresponding y value. So I will substitute x is equal to 1 back in this equation. So 2 times 1 minus 3. So y is equal to 2 minus 3. It implies that y is equal to negative 1. So the corresponding values, let's write them as coordinates. So 4 over 5 comma negative 7 over 5. That's the first point of intersection. And the second point of intersection gonna be 1 comma negative 1. Now we will see how they look like on the graph. All right, so we have got the graph, and what I have done, I have just zoomed this graph in order to show you the point of intersection. So the blue one is our graph of 3x squared plus y squared minus xy equal to 5. And the purple one is the straight line, which is y is equal to 2x minus 3. You can see these two are meeting at the point 1 comma minus 1 and 0.8 comma negative 1.4. You can go backward and you can see these points were 4 over 5 comma negative 7 over 5. We have got the same answer and we have got it algebraically. So this is what is, folks, when they will ask you to solve simultaneous equation, it means we are trying to find the point of intersection of the two curves. This is how you do it. I hope this video was helpful in your revision. Please put it in comments if you have any question, any doubt, any suggestions, any further topic that you want me to make video on. I'm happy to do so. Bye bye. Thank you for watching.